Hi, this is Santosh, and this is the Spark Foundation internship, task 4. In this task, we're supposed to explore the decision tree and visualize it. So, the data set that we're using here is Iris dataset, and I've started with importing the libraries, which is sklearn's dataset, so that we can get the Iris dataset, pandas, numpy, matplotlib. And then to visualize, I've used three functions in the libraries, which is the first one is sklearn external dot six import, from where I've imported string IO. Second one is IPython display, from which I've imported image function, and the third one is sklearns dot tree, from which I've imported export graph widths. And to overall visualize, we are going to use pi.plus. Now, over here, I have downloaded the data directly from the dataset library, which is load by dot load iris. This loads the iris dataset, and then I have visualized it or displayed the first 5 rows using the head function. You can see there are 4 features in this. Now, to get the target data set, we have to use iris data frame dot iris dot target. In this way, you'll be able to get the target data set, which has a column name as species. Now, further, what I've done is before we analyze, before we actually put this into the decision tree model of the algorithm, I have normalized the data by using the standard scaler. When I've imported this from sklearn dot preprocessing, okay, standard scaler, I've used the entire data set, which is the X data set, fit and transformed into normal, and this is how it looks. Okay, I've used the same index name and the column names as it is of X. Now further, I've split the data into train and test, where I'm using the sklearn model selections train test split function. With this, I have used test size to be 30%, and 30% means we'll be training out of 150 rows, we'll be training on 105 rows, and then testing it on the 45 rows. Further, I've used the decision tree classifier, okay, the algorithm from the sklearn.tree, and have trained the X train and Y train part of the data set. And after training, I've visualized the decision tree, as I mentioned in the beginning. We are using the string IO and then export graphviz, okay, to fit the data and uh, use the parameters accordingly, and then graph it using pi.plus, and then we can see the image with the help of the image function in by doing graph.create png. This is how our data decision tree is going to work. This is the visualization of how it's going to work with the given data set, which is X. Now I've done a little bit prediction to see how actually the model works. So we're going to use the function which is dot predict for the test part of the data, which is the 30%. And here we have predicted data. So we will further evaluate to check what is the accuracy. So I've made a small function over here, model train. This will train the model and also evaluate using confusion matrix, and then classification report. These are the things it will show up. Okay, now I am using the decision tree model, okay, and I'm putting the name as mentioned in the um, definition of the model train. So these are the two inputs that I'll provide, and this is the output that I get. Now looking at the confusion matrix, it sounds quite clean over here. The overall accuracy is 96%, precision for the first two categories is 100%, recall also looks quite good, and the FN score is 100, 92, and 92. So in order to explain or to interpret, I'm using SHAP. Okay, before we go ahead and use the SHAP, I have used the decision tree model again over here to show the prediction if, that it works perfectly. So over here I have used a particular row, just randomly picked up number 10. Okay, and then I am trying to predict the features in row number 10, and it gives me a prediction of 1, which is Satosa. Okay, and I am trying to check then with the y test, which has the actual value for the same row. Okay, row to show, which is 10, and it shows 1, which means our prediction is correct. Okay, over here I'm have installed SHAP, and then to see how the SHAP interprets, okay, I've used the explainer as the SHAP.tree explainer, and use the decision tree model and the X test data. With this, we are able to see the explainer how sepal length and petal length and petal width, these are the three features which is pushing the shaft towards 100% accuracy. Okay, and that's the conclusion. So I have enjoyed doing this decision tree visualization, quite exciting, and I hope you did the same. Have a great day.